So when we look at where the opportunity is for energy companies like Enbridge, and we're just one of many. We operate in the pipeline space for the most part, but there's no reason why the electric wire side energy distributors and transporters can't look to this technology as a way to make things more efficient and deal with business needs in a different way. We'll say this is a smart energy grid, not electricity grid. Because at the end of the day, we operate a pipeline and we've recognized ways to improve its efficiency. Starting from the wellhead, wherever you're gathering that natural gas out of the ground, you move it with gas compressors. There's a lot of heat that is dumped to the atmosphere. That heat can be turned into electricity through an organic Rankine cycle system. No incremental emissions. That's an efficiency improvement. We should be acting on it. When you get to the urban cities where we drop the pressure as a gas utility, we just squeeze that gas through a valve today. Through the hybrid fuel cell plant that I showed you, we can control the pressure, harvest that resource for power, and eliminate the smog-forming pollutants. That's another investment that can be made in this existing infrastructure to make it cleaner, greener, smarter. And when you start to deliver that energy to the end-use consumers, you can start to inject renewable methane. So increasingly, it can be a low-carbon fuel standard of the natural gas today, which is strictly drilled for its low-carbon properties. We can start to put more renewable content into that. And then as you start to put distributed generation into the hospitals, industries, down to micro CHP, it does a lot for the network as well. So a significant opportunity exists for emission reductions and GHG reductions through efficiency. Doesn't just need to be renewables that'll get us there. So this is going to be a video just to show you the process that we're talking about.
Enbridge's distribution system through a series of high-pressure pipelines. But before that gas can be delivered to our customers, the pressure needs to be reduced. So as it enters the system, the gas is squeezed through pressure reduction valves. This causes the gas to cool and expand as the pressure decreases. If the gas cools too much, the pipe and the soil around it could freeze. To prevent this, natural gas-fired boilers heat the gas before it enters the valve. As a result of this day-to-day pipeline operation, energy is being used without an increase in useful output. But it doesn't have to be this way. The natural gas flow is a source of energy that can be tapped for useful power output. By adding a turbo expander to the system, that energy can be harnessed. The turbo expander works like a water wheel in a river, but in this case, the river is natural gas. The flowing gas spins the wheel, producing clean electricity that can be delivered to local power grids, making efficient use of the everyday pipeline operations. To take it a step further, adding a fuel cell to the system can reduce the pipeline's impact on the local environment. A fuel cell generates heat and power without burning any fuel, reducing air pollutants and improving air quality and the health of urban areas. The heat produced by the fuel cell can be used to warm the gas, eliminating the need for boilers. This is an example of cogeneration that is linked to the pipeline's need for heat energy. The fuel cell's power can also be added to the system. The fuel cell's power output more than doubles the total production of low-impact electricity made available to urban power grids.
So hopefully that gives you an idea of the process that we have found a way to use fuel cell technologies. I guess the point that I would want to make is the more that can be done to get technology like fuel cells in end users, large energy companies, the moment they start to use it, they're going to think of its limitations and new ideas or opportunities to use it. That next generation innovation comes by getting this technology in the hands of those that are going to start to know its limitations and opportunities. Just to tell you a bit about the waste in our environment today, though, that small aluminum wheel you see in the picture is about 8 inches in diameter. That's the installed device to harvest a megawatt of power. That whole plant produces 2.2, so almost half of the resource is coming from what we harvest from waste on our pipeline. So there's a reason why gas utilities say call before you dig. There's a lot of embodied energy flowing in that gas. So this is a paper schematic of the animation you saw, but why do we marry these up? It's because technologies like fuel cells can make other technologies like the turbo expander eligible for renewable energy credits. From a policy perspective, this is very important. There are a number of things needed to draw capital investment to these clean and green technologies. So getting the policy right on things like fuel cells, so large energy companies down to small end users can make those investments, is increasingly important. So a little bit on its operations to date. The first year, when we had all the gremlins and other issues to knock out of the system, we had 93% unit availability. Year to date, in its second year, we're above 95%. So this is commercial. Although we did a lot of things different, first of a kind, this is not something that needs to be further tested in the lab. It's ready for wide-scale deployment. And when you look at the innovation on an efficiency basis, we're above 60% fuel to electric by combining these two devices. And we've validated in some applications 70% fuel to electricity. I know of no other technology right now that can do that. So when you look at the heat rates that we're able to generate, we can tune these plants for maximum efficiency or lowest possible emissions. So state policies, provincial policies that are after one or the other, you can start to have flexibility in how you would design these final plants. From a GHG emission perspective, I've shown the average US grid intensity for GHG emissions. I've shown a Canadian natural gas plant, best-in-class combined cycle turbine being next, and then the hybrid fuel cell is about half of the emissions of the US average. So that's not comparing it against coal, that's just the average emission intensity. So why would gas utilities do this? There's two reasons we see for them to invest in the technology, or at least allow this to be bolted to their system. If they invest in it, the electricity revenues from selling this green electricity justify the investment. That could be the utilities, and it could be a wire side improvement for the electrics, not a gas pipeline company. If they can get a net benefit in their system, they can put it in their rate base, it will pull that capital investment in these new clean green technologies. The other one is a joint venture where the utilities will basically sell the gas to the owner of the power plant, and they get new enhanced gas revenues under that format. So when you want to know the size of the opportunity, and this is just one application for fuel cells, there's a picture of the US natural gas interstate and intrastate pipelines. It shows some of the compressor stations, but from coast to coast, you've got an opportunity to install devices like what we've shown you, and it's just one application for fuel cells and other clean green tech. So for the policy limitations that we see, it would be very beneficial to go beyond what exists today as an investment tax credit for fuel cells. That's long-term federal support for the technology. But at the state level, there are opportunities for an efficiency-like renewable portfolio standard. These solutions that myself and the panelists will talk about today offer huge benefits in reduced emissions, lower GHGs, but because they may not be tied to what's today viewed as a pure renewable technology, they may not have the financial support in any kind of state policies. So that's going to be key to trying to move this more mainstream. And then there are some other regulatory barriers. Gas and electric utilities today are very restricted in what they can invest in. So the more that we can look and say, how can these energy infrastructure companies invest to make these systems more robust, smarter, and more efficient, we should be giving it consideration as to how we'd allow them to make these investments to draw capital investment to the types of technologies you're working on today. Thank you.
I'm going to stand here for a second as we get ready for the panel and discussion portion of this. Thank you, Dave. That was a great overview. Much of what we talk about here at the Fuel Cell Seminar has to do with the technology of fuel cells. But ultimately, all of the work that's being done in various labs, DOE programs, individual companies, will need to find its way home in the larger, to a home in the larger energy picture. What we're hoping to do today is to show through our discussion the ways in which there is a natural link between the U.S. natural gas industry, as large as it was shown on that map that David put up, and the various ways in which our technologies can be applied. So with that, I'd like to start with a few engaging comments with our panel, building a conversation around natural gas and fuel cells. And I'll get to a point where I'm going to open this up for questions among the audience. And we're going to try to keep this flowing for a good hour and a half. And our goal is that when all of you walk out of this room back to your own companies and your own labs and activities, you'll realize the importance of fuel cells and the value that the natural gas industry can bring to our industry. And with that, I'm going to start with one comment. The smart energy future was brought up. And there's considerable effort underway now to create an electric smart grid. A natural gas smart grid has both independent merit as well as a complement to the electric smart grid. I'm going to ask the panelists, how do you see fuel cell technology playing in the gas smart grid, or even more importantly, the energy smart grid? Want to start?
I'll take a stab at least framing the smart grid issue. There's a tremendous amount of investment that's currently being made in smart grid. There have been a large number of government grants that have been given for electric utilities to begin down this path. There's a tremendous amount of work going on across the industry with respect to how the interoperability of the smart grid. And if you hear anyone describe the smart grid, one of the things that you'll quickly begin to realize is that it is all about integration of technologies. It is all about integration of all of the various means that we might have at our disposal to create a more resilient, more robust, more responsive electric grid, along with utilizing those assets in the most efficient and effective way. One of those areas, of course, is distributed generation. It's one of the key drivers behind seeking support for development of the smart grid. And so as we think about distributed generation, as we think about the use of, in particular, natural gas as associated with distributed generation, then fuel cells become a natural fit for that application. And so as we think about it at AGL Resources, this issue of what will be the impacts of the smart grid on the upstream side of the natural gas infrastructure as these technologies begin to be integrated within the electric grid, as these technologies begin to be deployed, and what should our role be within the natural gas industry in helping to create the right environment, if you will, for the use of that kind of technology.
Jim,
Could I just follow
go
up
right
a
ahead.
little bit? Because I think a major piece of that is education component that you have a responsibility for as an industry. I know on the natural gas side of the industry, the INGA Foundation, INGA itself, the American Gas Foundation, APGA, American Public Gas Association Foundation, are all supporting a project which both Jim Marine and I mentioned on the vision for natural gas in a smart energy future. And we're trying to change the name from grid to something else. I mean, we kicked around network. Future seems like a real good way to put it, because there's so much that's not understood by policymakers in Washington, legislators, state commissions, on how everything all fits together. And so if fuel cells, and I've been in the energy business for a long time, and my knowledge of fuel cells is quite pitiful. I'm willing to admit that. And the longer I speak on fuel cells, you'll know that. But the point is that even for the natural gas industry, there's the average congressman on Capitol Hill is just not educated well about natural gas and where it plays a role. And so I think that's a big challenge for you guys.